Today we're writing algebraic expressions. We're taking words from word problems and translating them into expressions, something that we can do some fun math stuff with. So the first thing we need to understand is what words give us what operations. So we have a box on our page there, and to save a little bit of time and for the sake of those watching the video, we'll put it up on the screen. So the words that tell us that we're going to be adding are sum, plus, total, more than, or increased by. All of those words or phrases mean to add. So if I have the sum of 2 and a number x, how many of you are bothered by the fact that it says the number x? What are we, Roman? The 10? All right. So 2 plus x. The sum of 2 and a number x is 2 plus x. Or a number n plus 7. N plus 7. For subtraction, we have words like difference, less than, minus, or decreased by. Now, the important thing with difference, or with subtracting, and the difference between subtracting and addition, is that there's a very specific order when we're subtracting. So when it says the difference of a number n and 6, we have to start with n and then subtract 6. So it goes in order in that case. The difference of a number n and 6 is n minus 6. Or a number y minus 5 would be y minus 5. Now, the only time that that order is backwards is if we say less than. For instance, if I had something like 4 less than m, that means I started with m and I reduced it by 4. So I need to do m minus 4. That's really about the only time that it's backwards, is if we say 4 less than. Every other time you're going to want to go in order. Some of the words that mean multiplication: times, product, multiplied by seems pretty obvious, and of also means multiplication. So 12 times a number y, we could write as 12y. 1/3 of a number x, 1/3 times x. For division, we have quotient divided by or divided into. Now, if it says quotient, you're going right in order. The quotient of a number k and 2 is k divided by 2. When it's divided by and divided into, it's a little bit different. If I wanted to divide 4 by 2, I could say 4 divided by 2, and that would be 4 over 2, or literally 4 divided by 2. But that would be the same as saying 2 divided into 4. Now this one's a little tricky, because if I say 2 divided into 4, then we have 4 over 2. But if I throw the word parts at the end, then it's something completely different. Let me give you an example. 2 pizzas. I always like to relate it back to food. 2 pizzas divided into 4 parts. Then, if you think about it, I'm taking those 2 pizzas and I'm cutting them into 4 equal parts. And so I get 2 divided by 4, which is 1/2 of a pizza per person. Sounds like a good snack. So let's look at example 1. Example 1 says 4 less than the quantity. So notice it says quantity. That tells us that what comes next needs to be put together and done before the 4 less than. So 4 less than the quantity 6 times a number n. So I want to start with the quantity 6 times a number n. How would I write the quantity 6 times a number n? Seth? 6n. And I want 4 less than that. So where does the minus 4 go? Does it go before or after? After, because I'm taking 4 less than that quantity. That is 4 less than the quantity 6 times the number n. The next one says 3 times the sum. So I'm multiplying 3 by a whole sum. What do you think I'm going to have to do with that sum in order to indicate that I'm multiplying 3 by a whole sum? Yeah?
3s.
Well, I'm going to construct the sum out of 2 things. S isn't going to represent the sum because the sum comes next. They're going to tell me what to add. In fact, it says the sum of 7 and a number y. But what am I going to have to do with that sum to indicate that I'm multiplying 3 by the entire sum? Caleb? Put it in parentheses. Okay? So I'm taking 3 and multiplying by a whole sum. So I'm going to put that sum in parentheses. And it says the sum of 7 and a number y. How would I write the sum of 7 and a number y? Everybody else is afraid to chime in on a video, so I'll just pick on people. And now I'm going to have to call you by name. Ryan. 7 plus y. There we go. The third one says the difference of 22 and the square of a number m. Kyla, what operation is difference? Subtraction. So when I'm subtracting, I go in order. So what am I starting with? What's the first thing in my subtraction expression? When it says the difference of 22 and the square of a number m, what comes first? David? If I was plugging something in and evaluating it, then I would do the square first. But when I'm writing my expression in order, when I write it, what comes first? The 22. Okay. If I was evaluating, then I would do exponents first. But when I'm writing out my expression, I'm just translating it into math here. So what am I subtracting from 22, Sarah? And how would I write that? M squared. Okay, what symbol goes between the 22 and the m squared, Renia? Subtraction. Everybody okay with that? So we're going from words to math. All right, so let's take this and apply it to a nice word problem and interpret it. Example 2 says a piece of ribbon L feet long. So we've got a ribbon. We don't know how long it is. I'm calling it L feet. A piece of ribbon L feet long is cut from a ribbon 8 feet long. So that's cut off of an 8-foot ribbon. Write an expression for the length of the remaining piece. So let's think about this. How much ribbon did I start with? 8 feet. Okay, I started with 8 feet. Oh, I didn't. I don't have any ribbon. I'm ribbonless. I have yarn. I could have started with yarn. Okay, and what did I take off from that 8, Bethany? What did I cut off of that 8 feet? Nope. You're jumping ahead. Started with 8. What am I cutting off? Look at the beginning of the question. L. So I started with 8. I'm cutting off L. So what should I write for my expression? Start with 8, cut off L. Seth? 8 minus L is what's left. Started with 8, cut off L. I'm left with 8 minus L. If you think about it, if you start with 8 and you cut off 2, you'd be left with 6. So you'd do 8 minus 2. If you started with 8, you cut off 7, you do 8 minus 7 to get 1. So since we have this variable that represents an amount we don't know, we're going to subtract that from the 8. Make sense? Okay. Now sometimes it's helpful to throw a middle step into our approach, into our problem solving here. And one thing we could use with word problems is what's called a verbal model. And a verbal model is basically writing out in words what you should be doing. And then you can go back and insert numbers or variables to represent those words. So in example 3, it says you work with 5 other people at an ice cream stand. That's just a bad idea. Like, I would just eat all the profits. First of all, ice cream stands are small, and that's a lot of people to squeeze in an ice cream stand. Also, I've never seen an ice cream stand. It just kind of sits there in the bowl. Whatever. All the workers put their tips into a jar and share the amount in the jar equally at the end of the day. Write an expression for each person's share in dollars of the tips. So what we're going to do is we're going to start with a verbal model. Okay, so think about this. At the end of the day, you've got a jar full of tips, and you want to figure out how much each person gets. What's the first thing you want to do? Count it. So we want to know what's in the jar, right? So we're going to start with the amount of money in the jar. I'm going to write that. Amount in jar. So once I know how much money is in the jar, what am I going to do with all of that money? What am I going to do with that amount? Yeah. Divided by the number of people. So I take the amount in the jar and divide by the number of people. That's my verbal model. So do they tell me how much money is in the jar? I mean, it's me. People are giving me tips. There's probably hundreds of dollars in there. It's not fair for me to have to split it with everybody else who probably didn't earn any tips because I'm more awesome. Do they tell me how much is in the jar? No, so I should represent that with a variable. What do you want to what variable do you want to use? Z. Yeah, that makes sense. Could have used J for jar, could have used A for amount, but Seth wants to use Z. Let's go with Z. I think I see the problem. And I need to divide this up among the number of people. Now it says, you work with 5 other people at an ice cream stand. So how many people do I have to divide this up over? Bethany? 5. Ooh. Ooh, David. 6. Bethany is so generous. She's not going to keep any tips for herself. I want to work with Bethany. All right. So we're going to divide Z by 6 because, yeah, we have to count ourselves as well. That's really important. All right, so we take Z and divide it by 6. There's our expression. Now, another way we can compare quantities is with rates. A rate is a fraction that compares 2 quantities measured in different units. They have to be different units, okay? If they're the same units, it's not a rate. It's just a number, okay? So a rate is a fraction that compares 2 quantities measured in different units. If the denominator of the fraction is 1 unit, the rate is called a unit rate. You guys use unit rates all of the time, probably without even noticing it, and once you turn 16 and get your driver's license, you'll use unit rates every day. because when you drive down the road, there is something very important that determines how fast you can go. It's called a speed limit. The speed limit, the speedometer just tells you what you're going. The speed limit says where you can go. Okay? So the speed limit tells you how fast you can go. Anybody know the speed limit on Interstate 81? No, it's not 85. And it's not 81. 65. 65 what? Miles per hour. That means if you are driving at that rate, you will go 65 miles every 1 hour. So since the denominator here is 1, this is a unit rate. Okay, 65 miles in 1 hour. Everybody good so far? That's a unit rate. Let's look at example 4. It says a car travels 120 miles in 2 hours. 120 miles in 2 hours. So if I'm going to write a rate, that's 120 miles over 2 hours. They want me to find the unit rate in feet per second. So I have to convert those miles to feet and those hours to seconds. Now the key is we're going to use new rates, we're going to use new equivalencies, and we have to cancel out the hours and cancel out the miles. And in fractions, anything that's the same on top can cancel out with anything that's the same on bottom. So we're going to use what we call a unit multiplier or a unit conversion to switch each of these units. So how many miles equals how many feet? What's the conversion between miles and feet? It's a super weird number. This is why standard measurements are just weird. There are more than 13 feet in a mile. If there were 13 feet in a mile, the gym downstairs would be 2 miles high. Yes? 5,280 what? Feet make 1 mile. She's right. 5,280 feet make 1 mile. Don't get that backwards, okay? It's not 5,280 miles make 1 feet. Okay, that doesn't work, especially if you're saying 1 feet. Okay, so since we have miles on top in the first one, we want to put miles on bottom in the second one to cancel that out. So we're going to multiply by 5,280 feet over 1 mile. So when we do that, the miles are going to cancel out. We'll be left with feet. So we've already covered the distance conversion from miles to feet. Now we need to cover the time conversion from hours to seconds. Now in order to go from hours to seconds, where do we need to go first? Yeah?
There's 60 minutes and 1 hour.
Okay, so we've got to start there. We've got to go to minutes first. So since there's 60 minutes in 1 hour, and hours started on the bottom, we're going to multiply by a fraction with hours on the top. 1 hour equals 60 minutes. Then we can go, since we've canceled out hours, we can go from minutes to seconds. And we put minutes on top. 1 minute is 60 seconds. So when we multiply this fraction out, we're going to have 120 times 5,280 on top. You can throw the ones in there if you want, but they're not going to change anything. And on bottom, 2 times 60 times 60. So when we do that all out, we get a total of 88 feet per second. Because we canceled out all of the other units. All right, are there any questions? Okay, then.